So here is the first problem on that ACT prep worksheet. And so here it says the function y equals sine x and y equals sine x plus a plus b for the constant a and b, so a and b are just numbers, are graphed in a standard coordinate plane, so that just means it's graphed on a regular x and y plane. And then the function has the same maximum values. It does look like they both have the same maximum values. One of the following statements about the a and b is true. Which statement is it? Okay, so first, when I see a problem like this, I'm going to figure out which one is going to be the sine curve that's graphed. And then because I don't know what a and b are exactly, I just know that they're numbers, I need to figure out which one of these graphs is this guy, which is the shift. So the original OG graph for sine of x looks like it's this one, right? Because it starts at the origin and then goes up to the maximum, comes back down to the x-axis, then comes back up to the x-axis here, and then it just keeps going. So it looks like this curve here is the sine graph, just a regular sine graph. So the other one needs to be the shifted one, so the sine x plus a plus b. So when I'm looking at these two graphs, it doesn't really look like this one here, the pink graph, the shifted one, it doesn't really look like the graph has been shifted up. So what I'm saying is that there doesn't appear to be a vertical shift. So the vertical shift, the reason why I know that there probably isn't a vertical shift is because the maximum is the same maximum as the original graph. Okay, so is the minimum. The minimum is the original graph. So that tells me that this sine x plus b plus a plus b is not shifted at all. So that means that b here, if it's not shifted at all, we've learned that in this case, there's not a vertical shift. So b here has to be equal to 0. So in this case, the answer here is A. And that's just because I detected that this graph here has no vertical shift. And so that's how I know that the B here has to have been 0, because there's no shift. Okay, let's try out another problem. All right, so this one's an interesting problem. So problem number 2, it says that if x to y is equal to 5 to 2, and then y to z is 3 to 2, what is the ratio of x to z? Okay, first off, when I'm seeing a problem like this, what I'm trying to do is figure out how to get x and z. So what I'm going to do is take what I am given, so these two pieces of information. So when I take x and y and put it like this as a fraction, that kind of helps me out. And I am going to put it next to y and z. And so what I notice is that the goal is to try to get x and z, right? And so immediately when I write this out as fractions, I'm like, you know, if I could cancel out these y's and multiply this straight across, if I cancel out these y's, I can get the x by itself on the top and the z by itself on the bottom. And so there's a way I can do that, right? In multiplication, when you multiply this, technically, the y's are diagonal from each other, so they're going to cancel. If they cancel, well, this would equal x over z, right? Because you multiply straight across. So x times that got canceled, so it's just x. Y got canceled, so it's just z in the bottom. So I can get z this way with variables. Well, what does that mean if I have actual numbers or ratios? Well, x over y is really just 5 over 2. And I want to multiply this by y over z, which is 3 over 2. And so if I multiply these two, I should get x over z. So 5 times 3 gives me 15. And 2 times 2 in the bottom should give me 4. And so in this case, 15 over 4 can't be reduced, but it is one of these ratios here. So x here is 15, so it's this one, and z is 4, so it looks like that is our answer. E is our answer. So whenever you're given a ratio, right, two ratios, and you want to know what's the ratio of the others, try manipulating your ratios by turning them into fractions and seeing if you can multiply them to cancel out variables so that it looks like the variables that you want. So, neat trick. Alright, so in this case here, I have a geometry problem for you guys, and it's here a formula for surface area of a rectangular solid shown below. So here's the formula that they gave us for surface area, which just means like if you were to add up all the area on each side of the rectangular box, then you can figure out the area. Okay, and so L represents length, W represents width, H represents height. And what it wants you to do is by doubling each of the dimensions, so if you were to double L, W, and H, the surface area will be multiplied by what factor? Okay, so let me just digest what they're saying. So they're saying, like, if I were to double the length, the width, the height, how much, what would the factor be to the original surface area is what it's asking. So let's just think about it for a moment. So I'm going to bring down that formula. So we have A 2LW plus 2LW, oh sorry, not W, H plus 2WH. And so what I'm going to do here is basically every variable L, W, and H, I'm going to double it, meaning I'm going to multiply it by 2. So in this case, this is going to be like A equals, so there's that 2 in front, right? But then there is, let me write this in parentheses so that way it doesn't get too messy. There is that 2 times L and that 2 times W. So basically, these two, I've just multiplied it twice by 2. And then the next one inside is going to be 2 times 2L times 2H. So I'm all just multiplying this through 2 times 2W times 2H. So looking at this here and working this out, let's see if I can shrink this. There we go. Well, this just ends up being some, basic algebra here. The 2 being outside, there's a 2. And then if you multiply the inside here, 2 times 2 gives me 4. And then you have 4LW. And then same thing with this side. You would have 4LH. And 4WH. And so what I notice here is that all of these are now a 4 inside compared to the original, right? So that means that you could factor out a 4. You could factor out a 4 in each problem. And then you would be, if you factor out a 4 from each one of these, right? Just extract a 4 out. It's going to look kind of weird, but basically you would have like the same problem again. 2LW plus 2LH plus 2WH. Right? Because in this case, like all of these have a 4. And so if you take one out, all you're left with is a 2LW, a 2LH, and a 2WH. And so in this case, when you compare this new function, when you double everything, the length, the width, and the height, turns out you're multiplying this entire thing by 4. Whereas the original graph, this is the original area. And so it looks like it's about 4 times as much as the original surface area. So in this case, the answer is B. And that's just because you doubled it, and then if you're doubling the length and the width, you're multiplying that by 2. And so 2 times 2 gives you 4. And then each of them got multiplied by 2. Okay, so this problem here, I brought it up because we've been learning how to factor out numbers when we were learning how to find phase shift. So I thought at this point, you can kind of see how that can be applied here in geometry. Okay, let's try another problem. All right, so this problem here will be used, so this trapezoid will be used for the next 3 problems, starting with this one. So the trapezoid is on a coordinate plane, and it says, what is the slope of C and D? So first off, C and D is this slope right here. So I want to know from this point to this point here, what is that slope? Well, we learned in Algebra 2 that slope formula is y2 minus y1, x2 minus x1, where these x's and y's are coordinate points. Well, if you take a look at your trapezoid here, you actually have some coordinate points to work with, right? So you have a coordinate point right here and a coordinate point right here, the corners. And so you can use those corner points to find your slope. So if you make, this one, your x's, maybe this is your x1 and this is your y1, and then this is your x2 and that's your y2. It doesn't matter which one you choose to be your x1 and which one you choose to be your x2. So the top here would be like 4, or sorry, my y2 minus my 4, so that's going to be 1 minus 4. And then my 12 minus 9. And so if you work this out, this is going to be negative 3 in the top. And then the bottom here is going to be a 3, positive 3. And if you reduce that, that's negative 1. So in this case, the slope is negative 1. And ta-da, you're done. So even with a trapezoid, you can use the corner points to find the slope of the line. Okay, so this problem here, I have that trapezoid again, and this time around, I need to take my trapezoid, A, B, C, D, that's what they refer to the trapezoid, and reflect it on the y-axis. So here's my y-axis, right? It's right here. And it says, what is the coordinate for D, this D here, when you reflect it on the y-axis? So first off, let's just understand how reflecting off the y-axis works. So when you reflect something on the y-axis, like if I were to just take this A here since it's closer, right? So here's A. And if I were to reflect it over to this side here as the new A, if I really think about it, I don't think when you reflect off the y-axis, it changes the y value. Do you notice that? If you were to reflect this, the y would still stay the same, right? It would still be like a 1. However, I don't think the x value would be the same. Since that is 2 units away from the y-axis, right? It's 2 units away. Then that means it needs to be 2 units away to the other side, which would make it a negative 2. So do you guys remember, like in Algebra 2, you guys learned about the symmetry on the y? Like they would have the same height. You would like go up the same amount, but then you would go like, instead of going right, you would go left, right? You might remember that in like Algebra 2. You did that a lot when you were graphing, like parabolas, for instance. Well, in this case, it's a great way to apply that idea. So for D here, if we were to reflect it, right, the y value wouldn't change. The y value would still be at 1. So I'm looking for an answer where the y value for D that's reflected is still 1. So that means that I've narrowed down all of the answers except for F. And it looks like that idea holds true because I was saying that if this is, 12 units to the right, you're going to have to go 12 units to the left, which would make it a negative 12. So I really think that F here is the answer. Okay, so this last one here, same trapezoid going on. This one's a little bit tougher of a problem, and I am gonna explain this one a little bit slower. So this problem here is still a geometry problem, but what it's asking is like, which of the following vertical line cuts this trapezoid, A, B, and C, D, A, B, C, D, this trapezoid, into two trapezoid with equal areas. Okay. So let's just kind of grasp this for a moment. It's asking, like, if you were to somehow cut this trapezoid in half, right, it wants to make sure that the area of both sides are actually equal to each other. But it wants to know what x value does it hit it at. And so that's the mystery here. So, this is a tough problem. So first off, when I'm thinking of this problem, I think there's multiple ways to solve this problem, but for me, I'm thinking of this more logically, and I'm thinking about like, okay, area, if they're equal area, that means it's going to be the half of this original area. So the area of this trapezoid here, let's just go ahead and find first. So if you guys don't know the trapezoid formula, it's this right here. So the area for a trapezoid, I'll call T for trapezoid, is 1/2 times the base, actually the two bases added. So this here is one of the bases. You can call that like B1, and this would be considered the second base, B2. So basically you add your bases and then multiply by the height. That is your formula for the area of a trapezoid, okay? And so what I'm going to do is just calculate what's the area of the trapezoid right now for this full trapezoid. So to calculate this area, this would be 1/2 the base here. If you take a look at this base, it is this point is at 2 for the x, and that is at 12. Well, if I want to find the length of that, I would just take 12 and subtract it by 2, because the x-axis is going to help me represent that length. So in this case, B2 is 10, because 12 minus 2 is 10. And then B1, base on top, would be 9 minus 3, which is 6. So it looks like this length here is 6, this length is 10. So that's 6 plus 10 times the height. The height would just be the difference between, this point here to this point. So knowing that this point here, the y value is 4, and this point here, the y value is 1, if you take 4 and subtract it by 1, that means the height is, so the height here is 3. So I'm going to be multiplying this by 3. And so if I work this out, this is just 1/2 times 16 if you add times 3. Well, 1/2 times 16, well, half of 16 is just 8. Times 3 is 24. So this tells me that the area of this full trapezoid is 24. So that means if I want to figure out, what is the x value to cut this trapezoid, to figure out half of the area, I now know that half of this area would have been 12. Half of 24 is 12. So in that case, what I'm going to do is basically figure out a way to figure out what x is if I know that the area is 12. So let me put this to the side. So I want an area of 12. So here's what I know. I know wherever this x hits on the trapezoid, if I were to find the base right here for the top, right, I would have to take this x value and subtract it by 3, because in this case, if I were to find this length, I would have to take this x value and then subtract it to find whatever this length it would be. And so B1 would end up being, x minus 3, whereas B2, the bottom base here, would be this x value subtracted by 2 to figure out whatever the x, whatever the length of the base would be. I'm going to take x and subtract it by 2. And so that tells me that if I were to create a formula here, if I add these two lanes, I'm going to multiply that by 1/2 and times it by the height to figure out the area. Well, the other stuff is actually much more simple. So this formula here for the area is 1/2 times the base of the top and the base of the bottom. So my base here I'm calling x minus 3 added with x minus 2, because this is my base 1 and base 2 that are being added together. And then h here, well, h won't change. H is still going to be 3 no matter where x is. The height's not going to change depending on whatever x is. So height's still 3. So what you're trying to do is figure out what is this x that it's actually on to make them both equal to an area of 12. Because you know that that has to be half of the area because you calculated the original area and you know that it's 24, so half of it is 12. So all you have to do is figure out what is that x value that makes it 12. So if you work this out, you're just, going to work out inside the parentheses, combine like terms, like these two here, combine to make, let's see, 2x minus 5. Yeah, negative 3 added with negative 2 gives you minus 5. And so in this case here, we have a minus 5. I'm going to multiply that by 3 here in a moment. Actually, you know what? Instead of multiplying by 3, I could just divide that 3 over first. You don't have to. Yeah, I'm going to do that first. If I divide by 3, that cancels. Then 1/2 gets brought down. 2x minus 5 equals 4. And then if I want to get rid of this 1/2, I can divide by 1/2. And if you divide this side by 1/2, right, so this would be 2x. I guess I don't need those parentheses anymore. So since I've already canceled the 1/2, this is really just 2x minus 5 equals, well, 1/2, when you're dividing 4 with 1/2, right, like that, you're flipping the fraction. So 4, flip the fraction is 2 over 1. And so this would be 4 over 1, which is 8 times 8 on the top and 1 on the bottom, which makes it 8. So this is really 8. So if you keep working this out, you're almost there. I'm going to add the 5 over. And then 2x equals 13. And then if you divide by 2, x is equal to 6.5. 13 divided by 2 is 6.5, I believe. And so my answer here is E. Whew, that is a lot of work. And I think that took me 8 minutes to work out completely. So that is one way you can do it. And I think this is the more intuitive way. But I think this also is, I think there's also a trick too, but it's not so intuitive. Let me show you the other way you can work this out and how people have done this in the past. So what people have done in the past is if you have this trapezoid here, let me zoom in on this trapezoid for a moment, is you can take the length of the top, the points on the top base. So in this case, you're going to take your x values because, you care about the x values here and where it lands on the x-axis. So you can take your x values for the top here and add them and then divide them by 2. So 9 plus 3 divided by 2, well, 9 plus 3 is 12, divided by 2 is 6. Okay, and then you take the bottom, 12 plus 2 divided by 2, and 14 divided by 2 is 7. And then what you do is take these numbers and find the number, add those numbers, and then divide it by 2. So if you take 6 plus 7 divided by 2, that's going to be 13, which is 6.5, and so that would be the middle number. So basically you're taking like half of the original base and finding that, and then half of the bottom base, and then finding the halfway point between these two of the bases. And that's a quicker way, and I think that's great for testing, but it doesn't really, it doesn't connect to y very well to the area, and so that's why I showed you guys both ways. So I think it's best to know like y, but also, you know, when you're taking a test, it does matter on the time. So hopefully that helps you guys out. That's it for today's video.